pixelated universe, or Planck length. Try to zoom in, past your skin, past the cells, past the atoms, keep going. Eventually, you hit a wall. The Planck length, 1.6 times 10 to the power of negative 35 meters. Physics says you cannot measure anything smaller than this. It is impossible. Space itself stops being smooth and becomes grainy. Why? Because the universe is pixelated. In any digital image, if you zoom in far enough, you see the grid. You see the square pixels that make up the circle. The Planck length is the pixel size of our reality. It is the smallest unit of information the system can render. A smooth, continuous universe would require infinite computing power, infinite decimal points. But a pixelated universe, that is computable, that is efficient, that is a simulation. Frustum culling, or the observer effect. Now, let's look at the most famous glitch in history, the double-slit experiment. If you fire a photon through two slits, it behaves like a wave. A blurry cloud of probability. It goes through both slits at once. It interferes with itself. It has no physical location. But the moment you put a detector next to the slit, the moment you look, snap, it becomes a particle. A solid, physical object. Why does matter change its behavior just because you are watching it? In video game development, this is called frustum culling or occlusion culling. The game engine does not render the world behind your back. It only renders what is in your frustum, your field of view. Everything else is just mathematical data. Code unrendered assets. The universe works the exact same way. When you are not looking, an electron is just a wave function, a line of code. When you look, the engine quickly renders it as a particle. Here is your electron. Reality is not a solid stage. It is a render-on-demand system. It only exists when you need it to. Act 1 conclusion. The code, so we have a pixel grid Planck length. We have a max processing speed, speed of light. And we have an optimization engine that only renders what is being observed quantum mechanics. These are not accidents. These are constraints. They are the hallmarks of a designed system. A system built with limits, a system built to save memory. But if the universe is a computer, what is it computing? And what happens when it runs out of space? That is where the second law of infodynamics comes in. And that is Act 2. The second law of infodynamics, or Vopson's discovery. We are told that the universe is dying. Entropy, chaos always increases. Energy spreads out until everything is cold and dark. That is the second law of thermodynamics. But in 2022, a physicist named Dr. Melvin Vopson found something strange. He looked at information, genetic mutations, atomic structures, digital data, and he found the exact opposite. Information entropy decreases over time. Systems do not get more chaotic. They get more efficient, they optimize. Think about a zip file on your computer. It takes a large document and removes the repeated patterns. It shrinks the file size without losing the content. Vopson realized the universe does the same thing. Atoms arrange themselves to minimize information content. Viruses mutate to become more code efficient. Why would nature care about file size? A physical universe should not care. But a simulated universe must care. RAM is expensive. Processing power is finite. The system is constantly running a compression algorithm to keep the simulation stable. This is the second law of infodynamics. Reality is deleting redundant data to save memory. Black holes as hard drives or holographic principle. Now, so where does the deleted data go? What is the recycle bin of the universe? Black holes. For decades, we thought black holes destroyed everything. Information went in and never came out. But then Stephen Hawking and Leonard Susskind realized something profound. The information of an object falling into a black hole is not lost. It is smeared onto the surface. The event horizon, a 2D surface that stores all the 3D data of the object, like a hologram. This is the holographic principle. The entire universe might just be 2D information projected into 3D space. A black hole is the ultimate hard drive. It is the densest possible storage device in nature. It packs the maximum amount of data into the minimum amount of space. When a star collapses, it is not dying, it is archiving. The simulation is moving old assets to long-term storage to free up active memory for the rest of us. The Landauer limit, or info, is energy. Have you ever asked yourself, is information even real? Or is it just a concept in our heads? In 1961, a physicist bro named Rolf Landauer proved that information is physical. To erase one bit of information requires a specific amount of energy, heat. This is the Landauer limit. It links the abstract world of code to the physical world of energy. And in 2026, experiments are beginning to confirm it. Information has mass. A full hard drive weighs slightly more than an empty one. Imagine that. The data on your phone has physical weight. This means the universe is literally made of code. Mass is just information storage. Energy is just information processing. E equals mc squared. Energy equals mass times the speed of light squared. Code equals storage times processor speed. It is the same equation, just written in a different language. Act 2. Conclusion. The update. So, the universe compresses data to save RAM. It stores archives on black hole hard drives, and mass itself is just code. We are living in a highly optimized information processing system. But who is the user? Who is looking at the screen? Is it us? Or are we just part of the interface? That is where things get personal, because your brain is not showing you the truth. It is showing you a desktop icon. This is Act 3, the user interface. The desktop interface. Now, look around the room you are in. You see a chair, a table, a phone. You assume these things are real. You assume they look exactly like that, even when you aren't looking. But cognitive scientist Donald Hoffman says you are wrong. Evolution did not evolve us to see reality. It evolved us to hide it. Imagine your computer desktop. You have a blue folder icon in the corner. Is that icon the file? No. The file is a complex array of voltages and binary code on a hard drive. The icon is just a symbol, a shortcut. If you had to toggle individual voltages just to write an email, you would never get anything done. So the interface hides the truth to let you function. Hoffman argues that physical objects are just icons. A snake is not a long green tube. A snake is a danger icon. An apple is a food icon. Space and time are just the desktop background. We are not seeing the code of the simulation. We are seeing the graphical user interface, the GUI. If you actually saw reality as it is, you would go insane. So the simulation renders a simplified, user-friendly version for you to interact with. Change, blindness, and Troxler. Did you know your brain is the graphics card? And just like a GPU, it has limited bandwidth. It cannot process every pixel of the universe at once, so it cheats. It uses tricks to save power. Take the Troxler effect. Stare at a mirror for 10 minutes. Your face starts to melt. Monsters appear. Why? Because your brain stops updating the static parts of your vision. Neural adaptation. It assumes the reflection hasn't changed, so it stops rendering it. The monsters are just the brain trying to fill in the blank data with random noise. It is a texture loading error. Or look at change blindness. Experiments show that you can swap an entire person in the middle of a conversation and 50% of people won't notice. Why? Because you aren't looking at the person. You are looking at the concept of the person, the NPC tag. As long as the tag says, stranger in blue shirt, your brain is happy. It doesn't waste resources checking the details. We walk through the world blind to 90% of what is happening, because our render distance is set too low. The Mandela Effect, or version control, and then there is memory, the most unreliable hard drive of all. Millions of people remember Nelson Mandela dying in prison in the 80s. Millions remember a cornucopia in the Fruit of the Loom logo or the monocle on the Monopoly Man. Psychologists call it false memory, confabulation. But in software development, we call it version control conflict. Imagine the developers patch the simulation. They change the logo of a fruit company. They update the history of a political figure. They push the update to the server, but they forget to wipe the local cache. Your brain is the local cache. You still have the old pointer file, the memory of the old version, but the server shows the new version. The mismatch creates a cognitive dissonance. The Mandela Effect isn't a parallel universe. It is a git merge error. Some of us are running on an outdated patch. Act 3. Conclusion. The player, so we are blind. We see icons instead of reality. We hallucinate monsters in mirrors. And our memories don't match the server. We are not the admins of this system. We are the users. Or maybe we are just the avatars. If everything we see is a lie designed to keep us playing the game, then what is the point of the game? Why build a universe this complex? Why simulate pain? Why simulate love? Why simulate us? That is the final question. Act 4. The purpose. The Ancestor Simulation, or history reenactment. Why would anyone build this? It takes a lot of energy to simulate a universe, so there must be a return on investment. Oxford philosopher Nick Bostrom proposed the Ancestor Simulation theory. Imagine humanity survives for another 1,000 years. We solve climate change, we cure death. We have infinite computing power. What would we do with it? We would want to know where we came from. We would run simulations of the past, to study history, to see how we survived the 21st century. Maybe we are that simulation. We are a historical reenactment, running on a supercomputer in the year 3000. That explains why we live in such a critical time. Nuclear weapons, AI, climate collapse. This is the most interesting part of human history. The great filter moment. If you were going to simulate any era, you would simulate this one, to see if we make it. We aren't living in the present, we are living in a museum exhibit, the Boltzmann brain, or solo instance. Or maybe it is lonelier than that. Maybe there is no we, maybe there is only you. The Boltzmann brain paradox suggests it is statistically almost impossible for a whole universe to exist. It is much more likely for a single brain to randomly form in the void, complete with false memories of a life that never happened. You think you are watching a video on YouTube. You think you have a family, a job, a past, but those are just input signals. There is no internet. There is no Earth. You are a single-player instance running in a void. The simulation isn't rendering a world. It is just rendering your perception of one. It is the ultimate solipsism. If this is true, then you are the only real thing in existence, and I am just a voice in your head. A generated NPC designed to keep you entertained. The great filter, or the test, but let's assume we are all here. Together. Why, you ask? Maybe the simulation isn't a museum. Maybe it is a test. The Fermi paradox asks, where are the aliens? The universe should be teeming with life, but it is silent. Why, maybe civilizations don't survive. Maybe every time a species invents nuclear power or AI, they destroy themselves. The simulation might be a sandbox mode for developing consciousness, a safe space to test if a species can handle power without self-destructing. If we blow ourselves up, the simulation ends. Game over. We get deleted. But if we solve our problems, if we become peaceful, if we become sustainable, maybe we ascend. We get invited to the real universe. We pass the level. Earth isn't a home. It is an incubator. Conclusion. Play the game. So what do? If physics is code, if matter is data, if our eyes are an interface, doesn't matter. Doesn't matter if the steak is fake, as long as it tastes juicy? Does it matter if love is a chemical algorithm, as long as it hurts when it's gone? Real is just a word we use for persistent, and this simulation is persistent enough. We are here. We are playing. The only way to lose is to stop trying, to give up because it is not real. That is the trap the game wants you to play. It wants you to explore, to learn, to optimize. So look for the glitches, question the code, but don't forget to enjoy the graphics, because for now, this is the only server we have. If you want to decode more of the system, subscribe to Fudge here. We upload patches every week. Don't let your subscription expire before the simulation does. Welcome to the game.